Hi guys, welcome back to Worms Maths Academy. Today we're going to be going through sums and products of functions and addition of ordinates. So this, well, I guess it's sort of new for you guys, but you will have done it before but not actually realise that that's what you've done. So here I've got two functions. I've got one on root x minus 2, which we know is only defined when x is greater than 2, because if x was 2, the bottom would equal 0, and we can't divide by 0. And we also know that we can't square at negative numbers, so that's why x is greater than 2. Likewise here, 4 minus x has to be greater than or equal to 0 because it's under a square root. So then 4 has to be greater than or equal to x, or x has to be less than or equal to 4 if we rearrange it. So in this case here, we're given our domains, and what we want to do is we want to add the two functions together in the first case. So here, f plus g of x just means we want to add the two functions. So f plus g of x is 1 on root x minus 2 plus root 4 minus x. Now we want to work out what the domain is for the sum or product of some functions, like multiple functions added together. It's where the domains intersect. So what we do, quickly draw a number line. There's number 2 and greater than for this function, f of x. And then the other one is 4, including and less than. So the domain for this sum of two functions is from 2 to 4, not inclusive of 2. So we say x is an element of round bracket 2 to 4 square. Now that makes sense. If we use 2, that would make this one, the first function, equal, it'd be undefined, but anything above it's okay. And if we used anything above 5, this function would be negative. So for these functions both to work, the values of x have to be between 2 and 4. If I want to work out the addition of them, so f plus g of 4, that just means we've got to substitute that into the function like we usually would. So root 4 minus 2 plus root 4 minus 4. That's just 0. So answer is 1 on root 2 or root 2 on 2. So that's the addition of two functions. Now we've got the multiplication or the product of two functions. So if I want fg of x, so this is, later on we do something called fogs and goffs or composite functions. This is f of x times, keep forgetting they got this new feature, g of x. So f dot g of x means I just multiply the two functions together. So 1 on root x minus 2 times root 4 minus x. And that is root 4 minus x on x minus 2 when I multiply them together. My domain, once again, is 2 is less than x, which is less than or equal to 4. Okay, so it's whether it's multiplying or adding, or like addition, then our domain is where the two domains cross over. Later on, like you'll see with fogs and goffs, you'll see that it's a little bit different. Okay, so fg, the product of f and g was 3 substituted in. So fg of 3 means we substitute 3 into that function. 4 minus 3 on 3 minus 2. So we get root 1 on 1, which is just 1. And yeah, you could only evaluate between 2 and 4. You couldn't include 2, but you can include 4. Okay, now this is probably one of the things that students get most confused with, and it's not really a hard concept. It's just that everyone seems to get confused with it. So addition of ordinates, we've seen that for two functions f and g, the addition of those functions results in a domain of the function being the intersection of the two functions. I don't know what that W is from. Of the function being the intersection of the two functions. So if I add two functions together, f and g. The domain of f and g is the domain of f intersects the domain of g. So just draw a quick number line and go from there. So this is useful. This useful information combined with axis intercepts, stationary points and asymptotes can allow us to plot the graph of the functions when added. So what we're going to do is we're going to sketch these two graphs. So x minus 2 first. So of course it's got an intercept of -2. It's got a gradient of 1, so it's going to go through... I just cheated there. You might have been thinking, why? He hasn't gone anywhere near where he's supposed to. But... Okay, so that is f of x. And then let's change to, let's go purple. 5 minus 3x. So we've got 5. And then we've got a gradient of -3. So it's going to be there and there. Whoa. Okay, so here is that graph, that's g of x. Now, if I want to add them together, I can simply just add their y coordinates together. That's why it's addition of ordinates. We just add our y values together. So, if we have a look here, we've got 5, and here we've got -2. If I add 5 and -2 together, I end up with 3. Here, I've got -1, and here I've got 2. What's -1 plus 2? It's -1 plus 2 is 1. Now, if I add these two values here together, I've got 0 minus 1, which is -1. And then if I add these values here together, I've got, that will be 1, and then -4. So what's 1 minus 4 is -3. So we can see from here that if we draw a line, this is the sum of those two functions. So all I've done is add the two y values together. So I've added that value and that value together. I've added that value together. Here I've added that value and that value together. Then I've added that and that together, that and that together. So that's how we work out what our addition of, like our sum of two functions is. Now, if we look at this black line, we can work out it's got a gradient of -2 and it's got a y-intercept of 3. So y equals -2x plus 3. What happens if we add the two functions together? So if I said f plus g of x equals x minus 2 plus 5 minus 3x. If I add x minus 3x, I get minus 2x. If I have minus 2 plus 5, I get plus 3. Surprise, surprise, that's our function of when we added those two graphs together. Now you might think, oh, why don't we just add those two graphs together and then graph it? Well, this is a basic example, because we can also use addition of ordinates for harder functions that we don't know the solutions to. So, here we've got another example, x squared, so we know 0, 1, 1, 2, 4, -1, -2, 4. That's a really bad graph. Let's move it across and see if it looks any better. You get the idea. Not right. Okay, so let's get rid of this. Let's try to draw a better one by hand. So we've got that half, and we've got this half. Okay, and then I've got 2 root x, so 2 times root 0 is 0, 2 times root 1 is 2. 2 times root 4, so root 4 is 2, but when I multiply it by 2 I get 4. So my graph, so square root of 1 is 1, times it by 2 I get 2. Square root of 4 is 2, times it by 2 I get 4. So there's my other graph. Now, what did we say before? We said that when we add two functions together, we can only use the domain where they intersect. So the domain where these two things intersect, the first one is all real numbers, so there's 0. The other one, this one, is from 0 inclusive up into infinity. So the domain for f minus g of x is where those two domains cross over. So we've got x squared, then minus 2 root x, because we've got a minus in the function. And then our domain is x is greater than or equal to 0. Now, I've graphed 2 root x, but it probably would have been smarter to not graph 2 root x. It would have been smarter to just graph negative 2 root x, because I've got that negative there. We can just make this function negative 2 root x and then add them together. So negative 2 root x is going to have a negative 2, and then it's going to have a negative 4. So it'll look like that. Now when we add them together, or we're actually subtracting in this case, we're going to have, so here I've got 0, 0, so it's got to go through 0. Here I've got 1 and negative 2, so it's going to be negative 1. Then I've got 4 here, and we don't know exactly what that one is. That's 2 root 2. 2 times 1.4, it's negative 3.4. So it's going to be just above. And then you can see here, this graph goes up quicker than this one goes down. So it's going to go down and then up. Maybe not up that straight. So another way you can do it, one of my students, what they did, they basically, because we're adding these two values together, what they did was what did they do? They said, okay, this here is negative, so then they went to here and took away that much. Then this here is negative there, so they went to here and took away that much. They used a ruler, and they found this length, and then they subtracted it from that line. They found this length and subtracted it from that line. They found this length, and they subtracted it from their line. So then you get a good graph, and you can do that with your with a ruler in an exam if you needed to add two things together. So if you're adding these two functions together, because that's negative and it's negative 2, you get a ruler, you get that length, and then you go to here and then go down that length. Get this length, go to here, and then go down that length. If you are adding two functions together, so if you had a function that looked like that and one that looked like that, you could grab this bit here and add it on top, this bit here, add it on top, this bit here, add it on top, this bit here, add it on top, and then what are we doing? We're going to go here and then add that on top. So you can see that function is going to go up like that. But they used a ruler to do it, and I thought it was a pretty clever way to do it. Okay, so test your understanding. I've got 2 sine x and cos 2x for 0 to 2 pi, hence sketch the graph of h of x minus g of x. So, to make it easier, so f of x minus g of x is 2 sine x minus cos 2 of x. So I'm going to draw this graph as negative cos 2x because it makes it easier. Okay, so first off, let's start with 2 sine x. It's got an amp of 2 and a period of 2 pi. And then it's got what I call a chunk, which if you want to look up on YouTube, there's videos on how I use the chunk method. We just divide the period by 4, so 2 pi on 4, which is pi on 2. So that means every quarter of the graph occurs for pi on 2. So it's got sine starts in the middle. Every quarter of the graph is pi on 2, so there's pi on 2, pi on 2, pi on 2, pi on 2. So there is my graph of sine, 2x, 2 sine x. So that is f of x. Now g of x we're going to do as negative cos 2x. So my amp is 1, my period is 2 pi on 2, which is pi. So a chunk is pi on 4, and it's reflected in the x-axis. So it'll start at -1, and every pi on 4, that is when we do a quarter of the graph. So there, 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 and there. And we made it negative, remember? So it's already reflected in the x-axis, because this is an upside down cos graph. Not to be mistaken with the fact that there's a sine graph there that looks pretty similar. Okay, so that is negative cos 2x, and also we've got 2 sine x. Now we want to work out the addition of them. Let's use this colour. Okay, if I add 0 and -1 together, I get -1. Here I've got 0 and that value, so it's going to be that value, because if I add 0 to anything, it's just going to be that value. Here I've got 1 and 2. When I add them together, I'm going to get 3. Here when I add 0 and that value together, I'm just going to get that value. Here when I add 0 and -1, I'm going to get -1. So my graph's going to look something like that. Okay, if I add 2 negative numbers that are the same size, I'm going to get double it. So from there to there, from there to there, it just doubles. Oops. So let's say it's there. Okay, 0 and that value is going to be that value. If we add 1 and -2, that's going to be -1. If I add that value and this value together, it's going to be this value, because 0 and negative whatever. That value there is going to go down like that. And then if I add these two values together, I get that one there. So I go down, up, down, up. So that graph there is the graph of f of x minus g of x, which is also h of x. Now let's see how that looks graphically. I've got 2 sine x and -2 cos it, and then negative cos 2x. So let's clear this. So 2 sine x and negative cos 2x. Make sure my calculator's in radians. Tick, tick. Change my domain 0 to 2 pi. Let's go from -4 to 4. I think that's what I had on my graph. And then sketch. Okay, so there's our 2 graphs. Now if we add them together, let's see if they look like what we just did. So we've got our up, we've got our up and down, and then our little up and down. Looks exactly the same, I think, as what I did before. So we've managed to draw that graph without using a calculator, and we ended up with our final graph by using addition of ordinates. I'm just trying to think. They have asked questions like these in year 12, but they've been pretty easy. So all you're doing is adding the y values together, and from that you then get your added function, or your multiplied function. Of course, if you were multiplying, you'd have to multiply the y coordinates. But in this case here, where I don't think they can ask you for multiplying, but if you needed to, you just multiply the y values, and then you would get your resultant equation. So that's the addition of 2 functions, or the addition of ordinates. Okay, I'll be back soon with composite functions. Composite functions is probably one of the hardest things in the course. I enjoy it, but most kids don't, because this is why I said you need a really strong understanding of domains and ranges. So I'll be back soon, and we'll see how you go. Bye.